Hello everyone. So in this video we will discuss problem number 38. The question is a hexagonal lamina of sides 30 mm is resting on HP with one of its corners is in VP and its surface is inclined at an angle of 30 degrees with VP. The diagonal passing through that corner which is in VP is inclined at an angle of 45 degrees to HP. Draw the projections. Okay. So this is the question that they have given. Here the type of lamina is hexagon, the hexagonal lamina, so hence it is hexagon. So and what is the size of the hexagon? It is 30 mm sides. The first position is the normal position. We'll solve this problem again in three positions. So first position is the normal position. So what he is telling is, so it is a typical problem. So he is telling us, so we need to place the lamina in such a way that it is resting on HP. Okay, sides 30 mm is resting on HP. It means that it is resting on HP on one of its sides with one of its corners is in VP. Okay, so one side should be there on HP and one of its corners of the hexagon should touch VP. So this is the position of the lamina in the first position. Okay, so next is the surface is inclined at an angle of 30 degrees with VP. Okay, here you can observe the second position it is the condition with respect to second position. The surface, entire surface should make an inclination with respect to what? 30 degrees with respect to VP. Okay, third position condition is the diagonal passing through that corner. That corner means the corner which is in VP. The diagonal passing through the corner which is in VP is inclined at an angle of 45 degrees to HP. So this is the third position condition. By considering the second position and third position condition, so how do we take the lamina is the resting position, that is the normal position is, so this is the lamina that I will consider. Okay, so this is the position, this is the lamina that I will consider it as hexagon. Okay, so now what I will do is, so since it is one of its sides should touch your HP, so I will take this lamina and I will make it to stand on HP. I'll place this as my resting side. Okay, so if I consider, there are two possibilities I will show. So this, if this position I will consider, and if this is the corner, so that should touch to VP like this. So this corner should touch VP. So this is one position. Okay, and the other position is, instead of making it to sleep like this, I will make it to stand, this hexagon. So one of its edges, you can observe, the edge is touching to HP. Okay, and one of its corners should touch VP. So I will touch this corner F. So you can observe the namings. This point is A and this is B and this point is F. Okay, I'll take AB on HP and the point F should touch VP. Okay, I'll place it on the X line itself, this lamina. Okay, when I see this lamina, from the front, it looks like a hexagon. Okay, when I see this lamina from the top here, it looks like a line, horizontal line we will get. Okay, from the top view. We will get it as a line, but in the front view we will get it as a hexagon. This is what the position of the lamina is. So now let us draw the hexagon. This is the normal position I will consider according to the given condition. So front view we will get it as a hexagon. So with this AB as my resting side and this point F should be there in VP in all the three positions. Remember this, AB should be there on the X line, that is on HP, and F point should be there on VP in all the three positions. Okay, so now in this normal position what we will do, we will take its front view. If you see this lamina from the front, it looks like a hexagon. If I see this lamina from the top, it looks like a line. Right, that is the top view. Okay, so this is the construction we will do. So now, so if you observe normally, I need to obtain the corner towards my left hand side. Okay, so how to obtain this? And I also told you that AB we will get it on the XY line. So how to construct in this case is, so coming to the construction, so I'll take the construction part now. So first what we need to do is, so the size of the hexagon he has given. The hexagon size is how much? 30 mm. So what I did is, so with the help of the compass, by choosing any one point on this paper, so I drew 30 mm radius circle. Radius is 30 mm. Okay. So by drawing the circle, after drawing the circle, I have chosen the horizontal diameter. Okay, with respect to the center point of the circle. So with this point, with this diameter, so with the same 30 mm, by placing your compass at this point like this, so I'll show it now. First I have taken 30 mm. So with this center point, I drew the circle. So I should not consider the XY line at the beginning itself here. Okay, first I will draw the circle. So with this, after drawing the circle, I have taken this horizontal diameter. So with the same 30 mm diameter, I will cut 2 arcs on the either sides of the diameter on the circumference of the circle. Now you change your position of the compass, you place at this point, and you cut 2 arcs on the circumference of the circle on either sides of the diameter. So after cutting those arcs, so I will get 6 corners of the hexagon. So with this corner towards my left hand side. Okay, so I can tell you that, so this 2 edges, I'll join all the arcs. So with the help of dark lines, so that I'll get the hexagon. With the help of that hexagon, I'll explain. So this is the second edge of the hexagon. This is the third edge. So join them with the help of dark lines. Okay, this is the fourth edge. This is the fifth edge. This is the sixth edge. So join them now. So now I say that, so this corner I will consider it in VP, and what are the edge that is there below here, so that should touch your XY line I said. So now with respect to this edge, I have constructed the XY line. So place your scale on this edge base. So you draw a line like this. So this line should be your XY line. So once after construction of your hexagon, you draw your XY line in this case. Okay. So now this is X, this is VP above the XY line, and HP is below the XY line. So I have got the front view in the first position, isn't it? So front view namings I will do now. So this point I call it as A dash, this point I call it as B dash, C dash, D dash, E dash, and F dash. So once after getting all the 6 edges and doing the namings, you don't keep this circle. So you erase this circular part. So don't keep this. So this is how we need to obtain the hexagon. Right, that is your front view. So what about its top view? I have told you that we will get the top view on the XY line. So I will take the projections now. So take the projections with the help of thin line. If I extend the projections, we will get it on the same point. So here I will get it like this. So see, we will get it here. Okay, so top view, I will get it on the XY line here. So this point I call it as F. So this is A is nearer to the X line, so hence I should write it as E of A. So what about this? That is D of B. So what about this point? That will be C. So that because it is your top view, we should not put dashes for that. Okay. So what I should do next? I have told you that this F dash should be there on VP itself, that is on the X line, and AB should be there on HP itself. Okay. So now I'll show it with the help of the second for the second question. I'll show it with the help of this lamina. So I'm having the lamina like this here. I've chosen the lamina. So you can observe. So in the front view, it looks like a hexagon. So if I go to the second position, so I'll pull this lamina as it is. So AB should be there on the X line and F should be there on VP itself. So since it looks like a hexagon in VP, I should take the inclination with respect to what now? I should take the inclination with respect to VP. So now coming to the question, what is the inclination with respect to VP? We will see. Okay, second position, it is visible as hexagon in the front view. Okay, front view falls in VP, that is in the first position. Hence we should take the inclination with respect to VP here. So you can observe here, the surface is inclined at an angle of 30 degrees with VP. So what I should do? So coming to this, I should incline this lamina in such a way that F should be there on VP itself, AB should be touching to your HP, and I should incline this lamina with respect to VP like this. So this is the position of the lamina that I will get. So if I observe this lamina from the top, if I observe this lamina from the top, earlier it was horizontal line like this. So after inclination with respect to VP, so whatever the top view that was there, the same top view. So the same top view will get tilted to an angle of 30 degrees. What about its front view? So front view will get the hexagon, okay, of reduced size because it is creating some angle with respect to VP. So now let us see its construction. So what I should do, I have told you that the top view will get tilted to an angle of 30 degrees with respect to VP, and in the front view will get it as a hexagon. So now let us redraw that. So which is your reference point? I should take that F. F we need to obtain it on the XY line somewhere. So this point I call it as F. What is the angle of inclination he has given? He has given it as 30 degrees. Take 30 degrees now. So and if draw thin line, okay, and you obtain all the remaining corners. So with respect to point F, so from F to E dash of A dash, F to E dash of A dash, place at F and you cut the arc. Next F to D dash of B dash. So place at F again and you cut the arc here. Next again F to C. So place at F and cut an arc. Okay. So this is how we need to obtain all the corners. So you join them with the help of the dark lines. This much. So this is the point. So this point will be C. This is D of B I'll get here, and here I'll get it as E of A. So this is the inclination with respect to VP at an angle of 30 degrees. That is your top view. So what about its front view? We will see now. So first I'll take the projections horizontally because I'll get only two lines. So this is the second line that I'll get like this. Okay. So now you extend the vertical projections. This is F. So this is C line. Okay. So now D of B. So I should extend till D. So that is topmost line. So here I am having E as well as A. Among these two, E is above. I'll extend the line till there. Okay. A as well as B, I'll get it on the XY line itself. So now I'll do the namings. So this point is A dash because it is my front view. B dash, C dash, D dash, E dash, and finally F dash. You join all these 6 corners with the help of dark lines. So you can observe this problem. So the corner which is in VP is point F, and the edge which is in HP is AB. So please do remember that. That will be helpful for you in the third position now. Which is that point? The point F is in VP and the side AB is there on HP. Okay, now I have joined all the corners with the help of dark line. Okay, so I'll write that AB is the side on HP, that is the side on HP. F is the point. F is touching VP. Okay, so now I have completed 2 positions. First is normal position, second position is inclination with respect to VP. So I should go to the third position now. Third position condition is inclination to HP, or the condition with respect to HP. So what is the condition with respect to HP here? So this is HP I have taken. So what is the condition with respect to HP? Angle of inclination is 45 degrees. Okay. So what should make an angle of 45 degrees? So if I read the question, I will understand. The diagonal passing through that corner which is in VP is inclined at an angle of 45 degrees. He is just telling the diagonal. Okay. It means he is talking about the true diagonal. First let us see which is the diagonal passing through the resting point, which is that is there in VP, that is F. F is the point that is there in VP. So I should consider FC. FC is the diagonal, okay, passing through the point which is in VP. So this diagonal I need to consider, which is in VP. So I should consider the diagonal length. Since he is just telling the diagonal, so I should see the two positions now. Is there any possibility of getting the locus or not? Okay, let us check now. So this is the true diagonal. So if he is just telling the diagonal, he will be telling about the true diagonal itself. Okay, and this is my appearing diagonal. And this is my appearing diagonal. I'll write that here. Okay, so what is the length of the true diagonal in first position? Let us see. So this is the dimensions that I need to measure, and this is the diagonal length in the second position. Okay, let us measure now. So first position dimension is 60 mm, the diagonal length. This is 60, that is your true length. Okay, what about its size in the second position? Whether it changes? Yes, it is changing. It is reduced to 55. I am getting it as 55 here. So this is appearing length, that is 55. So here, so you can observe he is just telling the diagonal. It means he is talking about the true diagonal. But always we need to redraw the second position figure. I need this appearing diagonal. So what I should do now, since there is a variation of length from first position to the second position, I should consider this problem as locus problem. Okay, if in the question he has given the word appearing diagonal is inclined to VP, I would have taken this diagonal and have redrawn the figure. But in this case, it is a diagonal, just the diagonal. It means it is a true diagonal. Hence, we need to obtain the beta angle here now. Okay, first I will construct this. So we have understood that this problem is a locus problem or beta angle problem. First I will go with the inclination. So angle of inclination is 45 degrees with respect to HP. I will choose any one point on this XY line. So make use of your protractor and you take the angle of inclination as 45 degrees. Okay, so with respect to this, I'll take 45 degrees like this. Okay, so angle of inclination, I'll mark it as 45 degrees. This is with respect to HP. So now what I should do, I should consider the diagonal length from the first position, because he is talking about this diagonal itself, that is true diagonal. The diagonal, so passing through the point which is in VP, is inclined at 45 degrees. Okay, so hence I will take this diagonal length. I will choose any one point on this 45 degree line. Okay, and I will cut the arc. So 2 points I will get. With respect to the top point, what I will do is I will draw the locus line with parallel to your XY line, like this. Okay, so there is nothing to do with this first arcs what I have cut. Okay, this arc. Okay, so I need to redraw this figure, the second position figure. So now with the help of the first position figure, I will obtain the second position figure. I will take the dimensions of the second position diagonal length, that is appearing diagonal length. Take the dimensions from F dash to C dash. So this will be your reference point, that will be same. And you cut the arc and see where it intersects the locus line. So this is the diagonal length that is required. So in order to redraw the second position figure. So now what I should do, with the help of this second arc, I need to draw a line in such a way that the line has to pass through this intersection of this arc, and it should touch your reference point, and it should get extended to your XY line. So draw it carefully. So this is how we need to obtain. So whatever the angle of inclination, new angle of inclination, so that is the angle alpha here, because it is my front view. Okay, so now I'll do the naming. So this point will be F dash, and C dash point I'll get it here. So two corners I have got, two corners of the hexagon I have got now. How to obtain remaining four corners? So you can observe AE is there on same single line, BD is there on same single line. So these vertical lines are intersecting your FC, F dash, C dash. I am having F dash and C dash points. So these vertical lines are intersecting at some points. So those points I call it as 1 as well as 2. I'll obtain these two corners now in order to redraw the hexagon to obtain the final hexagon. So take the dimensions from 1 to F dash. Place at F dash. So we need to cut an arc on this new line that you have got, that is alpha angle line. F dash to 1. So I'll get 0.1 here. So this is 0.1. Okay. Now take the dimensions from 2 to F dash. Place at F dash itself and you cut the arc to obtain which point? That is 0.2. Now I need to draw the perpendicular lines with respect to this 0.1 as well as 0.2. So how to draw that? So make use of your protractor. Place at 0.1 along that alpha angle line. So you should not use that 45 degree line now. So mark 90 degrees. Okay. Similarly, mark one more 90 degrees with respect to this 0.2. Like this. Okay. Now with the help of the scale, you draw those lines, extend them on either sides like this. So on these perpendicular lines I will obtain the remaining four corners of the hexagon. That is why we are drawing this perpendicular lines. Okay, now I will choose the dimensions. I need to obtain E and A with respect to 0.1. Take the dimensions from 1 to E. It will be same from 1 to A as well. So place at 1 and if cut the arc on either sides of that line, of that point. So similarly, you choose the distance from 2 to D and B, that remains same as you have cut the previous arc. So now this is how we have to obtain the remaining four corners. Now I have got 6 corners of the hexagon. I need to join all of them now. Before that we will do the namings. So this is F dash. So after rotation I'll get A dash point here. This will be A dash. So this is B dash. C dash is there already. D dash and A dash. Okay. I have got all the 6 corners. You join all of them with the help of dark lines. Don't keep any extra lines. You erase all the extra lines here, extra projections what you have taken. So your diagrams has to be neat. So this is how we will redraw the figure. Extra lines, so let me erase. These are the extra projections that we have taken. So this is about third position front view. So now let us obtain the last step, that is third position top view. How to obtain that? So by making use of the projection lines. So take the projections from E dash of A dash. So these projections has to be parallel with respect to your XY line. So with respect to this point you take one more projection. Take projections again. So here also we need to take the projections with respect to point C. Now I'll go with the vertical projections. So you extend them to the required position. So A is here. So this point A dash to A. So A is there on the second line. Next B is here and B dash will get it here. That is third line. Sorry, second line. Next is C. Where do we get this C? C is the third line. C, D. Where is D? D is here. So we will extend the line from this point to this. Next is F. F we will get it on the XY line, right? Yes. So this point itself is F. Finally E. Where is E? E is the first line from top. This is the point. So this point is F. Okay. So do the namings now. So since it is my top view, without namings, without dashes, I need to put it A, B, C, D, E and F is here. Be careful. Okay. Now you join all of them with the help of dark lines in order to complete your last step. This is the final figure after inclination with respect to both HP as well as VP. So join D to E, E to F, and finally F to A. So we have done with this view, but what is the thing that I am missing is I need to measure this angle alpha. So place your protractor along your XY line and you measure the angle. I am getting it as 52 or 53 degrees. 53 degrees I am getting it. So you mark that as 53 degrees. Alpha equals to 53 degrees I have got. Okay. So this is how we need to solve this problem. So whenever he has given that, so one of its edges is in HP and one of its corners touching to VP, we need to consider the position of the lamina in this way. And here he has given just the diagonal is inclined to HP at an angle of 45 degrees. So it means he is talking about the true diagonal. So hence there is a variation, since there is a variation of length from first position to second position. So this problem is a locus problem because always we will redraw the second position figure. Okay, if there is any variation of the length, we need to go with the locus problem. Okay, so this completes the solution for problem number 38. So thank you for watching. Thank you, one and all.